All right, let's go through the questions from the Chapter 7 practice test here. Question number 1 is asking us to create our own slope field. And it's asking only at the 6 points here indicated. So all we have to do is plug in the x and the y coordinate for each of these 6 points into this differential equation. And then whatever we get, the output of that differential equation is our slope at that point. So we just draw a little line with that slope. So notice we're plugging in 6 different points, but if I look at it kind of in terms of the 2 different x coordinates, all of these 3 have an x coordinate of 0, and all of these 3 have an x coordinate of 2. And then so when I have an x coordinate of 0, the denominator is going to be negative 1. So then it's just whatever the y is squared and then make it negative. So if the y is 0, well, 0 squared is 0, and then make that negative. Well, that's still just 0, so there we go. 1 squared is 1, make it negative because the denominator will be negative. Something like that. And then a steeper slope for negative 4. And again, what we're doing here is we're just saying, okay, for example, plug in the point 2, or sorry, plug in the point 0 for the x, 2 for the y. 0 for the x is going to make the denominator negative 1, 2 for the y squared is 4, so 4 divided by negative 1 is negative 4. When the points jump over here, we have the same y coordinates, but the x is now positive 2. 2 minus 1 is 1, so it's going to be the same values, just positive. So I just need to draw that. So here's 0, here's 1, roughly, and here's 4, roughly. That's all. Next one. So in this case, we're asked to create a tangent line. And so anytime we're asked to create a tangent line, and the formatting here from Schoology is a little bit funky, so I'm just going to make it the way I want to make it. So anytime I'm asked to create a tangent line, it's y minus y1 is equal to m times x minus x1. And we're given the initial condition here. So that's y minus 3 is equal to m times x minus 2. And then my m is the slope, which is going to be the same differential equation as the previous problem, y squared over x minus 1. So given that initial condition, this is going to then be 3 squared over 2 minus 1. That just looks ridiculous. Minus 1. So that's going to be 9. And that's my slope. So my equation is y minus 3 is equal to 9 times x minus 2. Now we need to use this to approximate f of 2.1. So it's just plugging in 2.1. So we're going to say y minus 3 is equal to 9 times 2.1 minus 2. And if we work that all the way out, we're going to get 3.9. So that's my answer here. So this is my answer to the first chunk. This is my answer to the next chunk. In question number 3, we want to know which of these is the solution to the given differential equation. Well, we only know one way to actually solve a differential equation. We can use slope fields to approximate a solution, or we could do a tangent line to approximate, just like we did in the 2 previous problems. But the only way we know how to actually solve is if it's a separable differential equation. So sometimes when we look at a question like this, people want to say, okay, well, let me just solve this and then just choose which one is the solution. But because this is not a separable differential equation, I can't solve this. So the only option is to do what we did in our first lesson of Chapter 7 and actually just test each of these solutions and see which one works. So I'm just going to go through them one at a time. And so I need to know what is y double prime and then plug it into this equation and see what I get. So let's find y double prime. And of course, to find y double prime, I need first y, or y prime. Y prime for this first equation is going to be 2e to the 2x using chain rule. And then y double prime will be 4e to the 2x. So then I plug this y double prime into this differential equation and y into this differential equation and see if it makes it true. If it does, it's the solution. If it does not, it is not. So y double prime is 4e to the 2x minus 4 times y, which is e to the 2x. Does that equal 0? Yes, it certainly does. So that's my solution. I know the choices are going to be scrambled for yours, so that might not be your first one, or on the test, that might not be your first one. So let's just look at another one and see what might happen here. Let's jump down and do the sine one here, just for a little extra practice. So again, first I need y prime. Chain rule again is going to say that this is 2 cosine now of 2x. And then the derivative of that, chain rule is going to bring a 4 out now because it's 2 times 2. And then the derivative of cosine is negative sine. So it's negative 4 sine of 2x. If I plug that in, I've got y double prime, which is negative 4 sine of 2x. Right, just plugging in my y double prime to this differential equation, minus 4 times the original y, which I'm using the original y of sine of 2x. And I want to know, does that make the differential equation true? And in this case, does that make it equal to 0? Well, this time the negatives don't cancel each other out, and so I would actually just get negative 8 sine of 2x. So no. That's not the solution. The solution is only the first one. And again, for yours, it might not be the first one, but that's really the only way to do these. Yes, you might possibly be able to kind of see something, oh, I see how the negatives are going to work out, or to see whether it actually will be a solution, but in general, it does just come down to trial and error here. Next one is the same. It's sort of flipped. This time they've given us the answer and said, okay, here's the answer. Which one of these differential equations is this the solution to? Where in the previous one they gave us one differential equation and said which of these original equations is the possible solution. But the method is the same. Find y prime and y double prime and plug them in to each of these and see which one actually works. So y prime, chain rule, is going to be 3e to the 3x minus 5. And y double prime is going to be 9e to the 3x. And then the minus 5 will go away. Again, chain rule, because you're bringing this 3 down, and then you're going to have 3 times 3 to get the 9. Let's just go ahead and plug it into the first one, see if that works. Maybe we'll get lucky like we did in the last one. So y double prime, 9e to the 3x, minus 3 times y prime, which is 3e to the 3x, minus 5, and then plus 15. Does that actually equal 0? And these won't always be equal to 0. These two practice examples are both equal to 0, but it doesn't have to be. I mean, obviously we could take this same equation and just make it equal to negative 15, right? So they've just written it so that it's equal to 0, but it doesn't have to be done that way. So is this true? Well, if I distribute the negative 3, the 9e to the 3x, and then this will then become a negative 9e to the 3x, that will cancel out. This negative 3 and that negative 5, though, will actually become a plus 15. So I'll have 30 left on this side. So no, that doesn't work. No. but I can see, hey, this one up here is the same, just changing the positive 15 to a negative 15. So if all I did was change this here to a negative, now when I distribute and get a positive 15, and this is negative, hey, that will in fact cancel out. So it should be this one here. And if you don't see that right away, you just need to go through each of them and check to see, okay, does it make this equation true? Does it make this equation true? Does it make that equation true? Hopefully there's some patterns, some things you can take advantage to save a little bit of time, but that really is the best method there. In this type of problem where we're given a differential equation and we're asked to figure out which slope field works for it, there's a couple things we want to consider. And the first ones are, where do we see zero slope? Where do we see undefined slope? Where do we see positive slope? And where do we see negative slope? So just looking at this equation here, there's no value of either x or y that's going to make this thing undefined. And so if I look at my slope fields and I see some vertical tangent lines here, some vertical slopes, I know, okay, that's out because this one doesn't have any undefined slopes. Figuring out where this thing is going to be zero is a little trickier. It's going to be where x squared is going to be equal to the opposite of y, right? Which isn't, it's not super obvious, it's not super friendly, but if x squared equals the opposite of y, or you could say if y equals the opposite of x squared, so sort of along this negative parabola, this downward facing parabola, I should have zero slopes. I don't have a huge chunk of my graph to be able to find that though, so that could be a little tricky to see. But if this is true, then the left or the right hand side is going to be zero, so you're going to have zero slope. So there's none of these that I really see an undefined slope. I see some fairly steep slopes, but nothing truly undefined. The zero is a little hard to see. I do know I should have zero slope at 0, 0, which it looks like all of them do. And I can use that, but I think there's a better option. The better option, I think, is that as long as as long as y is positive, this will always be positive. So quadrants 1 and 2 should always have positive slope. And so I'm looking for any negative slope up above the x-axis. This has negative slope here, so that's out. This has negative slope here, so that's out. Negative slope, so that's out. This is the only one that has all positive slope wherever the y is positive, because the x will always be positive. So as long as y is positive, the overall slope will have to be positive. Now, I'm not saying that's the only place you have positive slope. I'm just saying that that is a true statement. If y is positive, the slope will be positive. So it's got to be this one. And you can kind of see that pattern of zero slope. You have got a zero slope here at 0, 0. 1, negative 1 should have zero slope there. And you can kind of see that downward facing parabola being formed here with your zero slopes. But it's a little hard to see that, because as long as y equals negative x squared, you have zero slope. Next one follows the same idea. Flipped again, though. We've given you one slope field, and you have to pick which of the several differential equations fit for that. And first thing I notice here is that along the y-axis I have zero slope, and along the x-axis I have zero slope. So when either x or y is 0, we have 0 slope. Not undefined slope, but 0 slope. So I think that tells me that these are out, because in either of those, if the y was 0, the slope should be undefined, not 0. And then in both of these, if either x or y is 0, the overall slope is 0. And now as I look at my positives and negatives, I see I have negative slope here in quadrant 1 and in quadrant 3, and positive slope in quadrant 2 and 4. Well, that's the opposite of what I would expect, because we've changed the sign here. So this one is my actual answer. All right. I'm going to stop this video here, and then I'll pick it up again for the last two problems.